Good morning, my name is Vitória Tavares, and I'm going to present this rapid systematic review entitled Saliva is suitable for SARS-CoV-2 antibodies detection after vaccination. The authors are me, Juliana Amorim dos Santos, Hélène Chardin, Ana Carolina Acevedo Poppe, and Eliete Silva Guerra. Since the introduction of new vaccines for COVID-19 control, the antibody quantification becomes very useful to make a populational follow-up. It's reported that antibodies anti-SARS-CoV-2 decrease with time after vaccination. So this populational follow-up usually is performed by serological tests. However, salivary tests can be an alternative for that with some advantages, as being non-invasive, painless, has an easy collection, and can be self-collected by the person. And this is why it has a lower risk of contamination. And it can be done in a large scale follow-up. So the aim of this review is to analyze if saliva sample is suitable for SARS-CoV-2 antibodies detection after vaccination. We use the acronym PICUS. Population is human vaccinated for COVID-19, infected or uninfected. The intervention is anti-SARS-CoV-2 vaccine. The control is human unvaccinated for COVID-19. And the outcome is the detection of SARS-CoV-2 antibodies in saliva. We included observational studies. So we used 3 databases, InBase, PubMed, and Web of Science, and we found 134 articles. However, we included 15 studies in this review. About the location, most studies are in Italy and United States. However, there were some studies in Germany, Canada, Croatia, and Australia. About the type of vaccine, our studies evaluated the Pfizer vaccine, and they also evaluated Moderna and AstraZeneca and Johnson & Johnson. So the method most used for saliva analysis was ELISA, followed by the multiplex assay. For the immunoglobulin analysis, the most evaluated in saliva was IgA, followed by IgG, total IgG, and IgM. The antigens used for access the antibody. Most of the studies used the protein S, followed by RBD and nucleocapsid. For the method for collection of saliva, cotton was the device most used. Some studies reported a correlation between the concentration of antibodies in serum or plasma and saliva, and the mean correlation for IgG was a moderate correlation, and for IgA was a weak correlation. When we analyzed the antigens separately, there was no difference between the protein S and the protein RBD. So for IgG, the correlation is still moderate for both antigens, and for IgA, the correlation is still weak for both antigens. Some studies reported sensitivity and specificity, and sensitivity was higher with a value of 91%, and sensitivity had a value of 87%. Some studies compared the antibodies in people previously infected to people vaccinated. So the first graphic shows EGA, and EGA was higher in people previously infected when compared to people only vaccinated. And the second one shows EGG. So EGG was higher in people vaccinated when compared to people previously infected. So in conclusion, the concentration of antibodies in saliva was lower than in blood. EGG is often present in saliva, while EGA is rarely present. About the correlation of the antibodies in saliva and in serum, for EGG is a moderate correlation, and for EGA is a weak correlation. And also this study highlights the importance of new strategies of vaccination, as a vaccine focuses on mucosal immunity. So saliva is an alternative biofluid suitable for detection of SARS-CoV-2 antibodies in vaccinated and previously infected individuals. Thank you very much. You can scan the references if you want.